Okay, here is the last video for this lesson. Like I put down in the directions in Google Classroom, if you haven't already, go to that second PDF and do the problems that involve finding a missing side. And then the last thing we'll do is find missing angles, and that's the last set of problems that's in the assignment. This guy will be due on Friday. Today is Wednesday, so Friday, April 10th at 11 o'clock. I mean, have it done before the Zoom meeting if you want to ask some questions or go over some problems there. I'm also going to try to do something new at that meeting, so it'll be great if you could check in. But let's just do a couple problems and then you can go do some work. So just an Algebra 2 thing. You guys are all very familiar with this. Inverse functions. You know that when you write an inverse, what you end up doing is switching the x with the y. The input becomes the output becomes the input. So some examples that we've done. Function y equals x squared, inverse y equals the square root of x. Square root undoes x squared. Put 3 in, out comes 9. Put in 4, output is 16. Go to this function, use 9 as your input, output is 3. Use 16 as your input, square root 16, 4. So input became output, output is the input. Exponential, 2 to the x. 2 to the third, 2 times 2 is 4, times 2 is 8. 2 raised to the 5th power, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So input 5, output 32. The inverse of 2 to the x is the log base 2 of x. Try those on your calculator. Emma, let me know how that went if you got a calculator. So math, log base, base 2, and I'll just do one of them, 32. Input is now 32. Output is 5 because 2 to the 5th is 32. Okay. Inverses. Now go to look at trig. You know that y equals the sine of x means when you put in the angle, out comes the fraction that was made by opposite over hypotenuse. That fraction is the output. Now this comes from a table of values that some mathematician made a long time ago, and he did it by building triangles and looking at angles and ratios. Just kind of like the log table. It's already done for us. We just have to look it up, and we use our calculator to look it up. Okay? So if I did the sine of 30, now the thing to make sure of always is make sure my calculator is in degree mode. Okay. Now if you want like this, y equals, and you did the sine of x, you have a function. Now I'm going to set my table to be an ask for the input. So now when I go to my table, there's nothing there. So if I do 30, enter, out comes 0.5. 45 degrees, 0.7071. 60 degrees, 0.8660. Okay, so there is the function. You put in as input the angle. The output is the fraction that would be built from the sides of a triangle turned into a decimal. Okay. So the inverse sign must do the opposite. It must take as input the fraction built from the sides, and the output would be the angle that you were using. Now your calculator, as you've done this in geometry, has the inverse trig functions right above sine, cosine, and tangent. So you can actually do them. So if I went like this, clear that, and did second inverse sine, and use the variable x, calculator likes variable x, and now went to my table and put in 0.5 as my input, out comes 30. Okay, so the input is the fraction made from the sides. The output is the angle that you are working with. So if I do, now this is going to be approximation, but 0.7071 at 44.99 due to rounding. And then if I did 0.8660, get really close to 60. Now I don't know if you guys remember from geometry or not that there's some actual values here, like the cosine and sine of 45 is actually square root of 2 over 2. So this is just decimal approximations to what it really comes out to be. But the thing to remember is that when you have inverses, the output and the input switch. And so if we want to find an angle, we can put as the input the fraction that was made from using the two sides we needed when we worked with this angle. All right, so we go down to some problems. We're going to find the missing angle. Now, if you do it all from the very beginning, I'm not sure how we did this in geometry, but you say, okay, I'm standing here. There's the right angle. That's hypotenuse. This side helps make the angle, so that's the adjacent. So ka, there it is, toa. So the cosine of the angle has to give me the fraction adjacent over hypotenuse, 13 over 18. Okay. I'm looking for that angle. So what I have to do is undo this function. I have to do the inverse. Now you can go right from this, knowing you want to find an angle. Say, okay, to find the angle, I use the inverse cosine. Now the inverse cosine needs the fraction that would give me the cosine of the angle. Instead of inputting the angle, I input the fraction. So 13 over 18. Just like up here. When you input the fraction, out comes the angle. So now I just go to my calculator. And do the inverse, so second cosine of 13 divided by 18. I think like in a lot of people in geometry call this the cosine negative, -1, but that's not what it is. Remember, that's the notation for the inverse function. That's like, that's kind of like this. That's f inverse. It represents the inverse function. So this is the inverse cosine. Hit enter, and the output is the degrees. So theta is 43. What do you want to round to? Let's do round nearest nearest degree. So let's round to the nearest whole degree. So 43.7 is 44 degrees. Classic, use a tree and find some stuff. So you know for some reason that the tree is 50 degrees, or I'm sorry, 50 feet tall. How you got that, I don't know. Probably used trig. And then you pace out 20 feet this way. And the question is, if you were to tilt your eyes from level and tilt it up until you elevated your line of sight until you saw the base of the tree right here. This angle is called the angle of elevation. What's that angle? This is a classic problem. So you say, okay, if I stood on this angle and named these sides, this is the opposite side. And this is not the hypotenuse. There's the hypotenuse. Side that makes the angle is the adjacent side. So this is the adjacent side. So opposite adjacent is tangent. So to find the angle, I will do the inverse tangent. The output is the angle of the fraction that tangent uses. So this is TOA. Tangent uses the fraction opposite over adjacent. So I do opposite over adjacent as the input to this inverse function. Oh. Second tangent, 50 divided by 20, 68.19, which is 68. So theta is approximately 68 degrees. And that's all there is to it. Just recognize that you're looking for an angle, so you're going to use the inverse function along with the fraction. Pretty cool. That's algebra 2. Right. Now you can have the directions solve the triangle. When you solve a triangle, you find the measurement of all 6 parts, the 3 sides and the 3 angles. With a right triangle, angles are easy. So I'll give this guy a name. I'll call it theta. So that's 90, that's 51. So to find theta, you can just take 90 degrees and subtract 51. You know, all 3 angles have to add up to 180. So in a right triangle, the 2 non-right angles have to add to 90. So 39 degrees. Okay, so there's first thing. All right, now you want to pick a side. So give it a name, X. All right, so now you have any angle you want. And if you plan ahead, it'd be nice to have this variable on the top of the fraction. It just makes the steps one less than the other way around. So let's see, we'll use this guy here. Okay, so this is the opposite for this one. And let's see, there's the right angle. So this is the hypotenuse always. And that's going to be for 51, this is the adjacent. So opposite and adjacent are the 2 that I know. So opposite, adjacent, tangent. Tangent always comes up. So the tangent of 51 degrees, because I'm using the 51 to describe these 2 sides, has to be the opposite side over the length of the adjacent side. Right. This is just a number. It's going to come out to be a decimal. So instead of finding the decimal there and writing it down, I'll just carry this whole function notation around with me. 1 times x, x, and then cross multiply 7.3 times the tangent of 51. Now really what we're doing is we're multiplying both sides by this. We're not mathematically, we're really multiplying through by the common denominator. But thinking cross multiplication works the same. So then I go ahead, all right, I do that guy out. 7.3 times tangent 51, 9.01, go back and round, nearest tenth, 9.0. Okay, so this guy is 9.0. Now once you have two sides, you could do the Pythagorean theorem. Legs squared plus legs squared equals the hypotenuse squared, and do the Pythagorean theorem. Or you could go do another trig ratio. And that's what I'm going to do. So I'll use the 51. I want to find this. This was given to me originally, so I'm going to use that one. So adjacent and hypotenuse. So the cosine of the angle, the cosine of 51, adjacent side over hypotenuse. Since that has an h there, I'll just use the variable h. Now this is a bummer because I just wrote an equation that's going to make me have 2 more steps. So I think about this as being over 1, cross multiply, 7.3 equals h times the cosine of 51. And you don't have to write a times sign here. It's understood if you don't write it, but I'll put it in. The cosine of 51 is a number. I have a number times h. So to undo that multiplication, I divide by the number that I would get if I did cosine 51. Whatever you do to one side, do to the other. Right. So these would divide away. It's all of this. Not just the 51s, it's what you get after you take the cosine. That leaves h. And now on this side, I will do 7.3 divided by cosine 51 degrees. 11.6 is the other side. So here's my triangle, rounded to the nearest. That's 90, nearest tenth. That's 51. This guy's 39. Those add to 180. This is 11.6, 7.3, and 9.0. All rounded to the nearest tenth. Solving a triangle. So that's like the most longest anyways, solving a triangle problem you have. Finding all 6 pieces. Great. Talk to you on Friday.